Hello, everyone. I'm here to give you a refresher on graphing linear functions. We're going to go over graphing in both slope-intercept form and graphing in point-slope form. Let's get started. Okay, first off, graphing in slope-intercept form. So when you graph in slope-intercept form, you need to make sure that it's in slope-intercept form. Y equals mx plus b. The m stands for slope, okay? The b is for the y-intercept. I'm actually going to circle those so that you know that those are the things that we are looking for, okay? Slope, y-intercept. Now you start with the y-intercept when you graph a linear function, okay? You should be starting with the b value, positive or negative, okay? Then you're going to graph the slope from that y-intercept, okay? The example over here is graphing y equals 3x plus 2. So if we start at 2, our slope is 3 over 1. So we're going to go up 3, 1, 2, 3, and put another dot. And you're going to do that multiple times to create a line, okay? Slope is always rise or up first, then run or over first, over second. Up first, over second. Okay, we're going to move on. Okay, so we're going to graph, we're not going to graph all these, we're only going to graph a couple of them, okay? So let's erase the drawings. Okay. First one I want to graph is number 1, okay? Number 1, graph the line 2x, y equals 2x plus 3, okay? Y-intercept first, or the constant value, plus 3. So what you're going to do is on the y-axis, look for positive 3, which is right here. I'm actually going to get a thicker dot. Okay. Y equals 2x plus 3. We started with 3, which is our y-intercept. Next, we're going to go with the slope. Our slope is 2, but every slope is a fraction. So 2 over 1. So from that dot that we placed on the coordinate plane, we are going to go up 2 and over 1 right here. Do it again. Up 2 over 1. Up 2 over 1. Then you're going to create a line. That's how you graph in slope-intercept form. Now, this one, I think, is how you're going to solve most of them. Most of the time, you will see a linear function in slope-intercept form. So we're going to practice another one. Okay. Graph the line y equals 1/2 x minus 4. There's one thing that's different about this one. And that one thing is not only that the y-intercept is negative, but our slope is actually a fraction. So let's start with the y-intercept being a negative. So on the y-axis, find -4 right here. Okay. Our slope, 1/2. Now remember, rise, run. So we are going to rise 1 spot and run 2 spots. Make a nice dot there. And you're going to do it again. Up 1 spot over 2 spots. Make a nice dot. Up 1 dot over 2 spots. Another dot. Okay. Once you have all of your points graphed or enough to draw a line, you will make a line. Now, normally your line is going to be expected to go through the entire graph like this. That's my expectation on any assessment, and really any math teacher that you'll ever have, that's their expectation too, is when you graph a linear function, it'll go through the entire graph, not just the dots that you make. Okay, next. I want to do just one more because the next one is what is very challenging for a lot of students. Noticing that there can be a negative here, okay? Now, this whole slope is negative. I'm going to show you what I mean by that in just a second. Let's start again with the y-intercept, which is +6. So we'll go up to +6. Nice, solid point. Okay. -1/3. The question that I always get as a math teacher is, which is negative, the 1 or the 3? And the answer is, it doesn't matter. So we're going to go, let's say you wanted to make the 1 negative. You go down 1 and to the right 3. So down 1 spot, 1, 2, 3, right there. Let's say you wanted to make the 1 positive and the 3 negative. Well, positive would be up 1, negative for running, or the x-axis, left, 1, 2, 3. You notice how those still fall on the same line? That's because it doesn't matter which way you go. You can either go up or down, left or right. But as long as your line ends up looking like a true negative slope, it really doesn't matter. So for number 3, your line should look like that. Number 4. I'm not going to graph this one because if you've watched me graph the previous 3, you should be able to graph number 4, except for one thing. In front of x, there is no coefficient. Or is there? There is one. Anytime you see a variable by itself, the coefficient, or the number in front of the variable, 1. So this equation is y equals 1x minus 9. And then you can graph it because the slope would be 1/1. You can graph accordingly. Okay. Next, we are going to move on to point slope form. Point slope form always gives students, of mine at least, trouble. And that's because it's a little weird. The coordinates here of x1 and y1, a little strange. Because the minus signs throw students off all the time. Okay, we're going to work through it together. What I want you to know is that point slope form, not as widely used as slope intercept form. Okay, it's not as widely used. Slope intercept form is much, much more prevalent. So let's get to note taking. So first, graph the point x, y. Okay, so in parentheses, there's an x minus a number, and then on the other side there's y minus a number. If it's minus, and this is where everyone always gets tripped up, if it's minus, it's a positive. Weird. If it's a minus here on this side, it's also a positive. So for this, y minus 2 equals x minus 3, you're going to graph positive 3, positive 2. And I'll show you what that looks like. Positive 3, positive 2. Now, remember in the last one when we talked about if there's no coefficient, the coefficient's 1. That's what we have here. Look. So from this point, you graph the slope of 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. That is your linear function. And you would draw your line signifying this function, right? You'd be done. So the only difference is you have to start with this point. Now I want to write you a note. If it is negative, no, if the points are negative in the equation, graph them in the positive. Just like we did here. It says minus 3, minus 2. We graph that as positive 3, positive 2. And then from that point, we graphed the slope. Up 1, over 1. Okay. If you need to write this down, I would do that now. I'm going to erase everything. So just give me 1 second. Okay. Let's try the other side of it. Okay. Remember I told you if it was negative, graph it positive? Works the other way too. These are both positive. We have plus 2, plus 5. That means we're going to graph them negative. Negative 2, negative 5. Now again, it's a little weird. I know that. I understand that. But it goes down to a different way of representing a linear function. So we graphed our point. The slope here is 2. But remember, anytime we have a slope of a whole number, it's actually a fraction, 2 over 1. So now I'm going to graph from this point up 2 over 1, up 2 over 1, up 2 over 1. And I can do this again forever and ever and ever. Then you connect all your dots. Make sure your line goes all the way through your graph. We are done. Point-slope form is probably one of the more challenging ways to graph. Slope-intercept form is much easier. Okay. Last but not least, I wanted to give you all a little tip on if you're struggling with this. Okay. The biggest tip I could give, practice, practice, practice. You need to practice graphing or else you will not get better at it. It's like anything. So you can practice on IXL. You can practice on Khan Academy. You can even find videos on YouTube of someone doing what I just did with you, where you can practice more and you can get that instant feedback on how to graph. You can pause the video of when they show the problem, try graphing it yourself, then watch the video and see how they graph it. Okay. I hope this video finds to be useful for you. Good luck and have a wonderful day. Bye.